You have been told this your entire life. You heard it as a child, probably from someone older, probably standing over a garden bed with a spade in their hand. A worm gets cut in half, both halves grow back. Two worms from one. You may have tested it yourself, watched the severed pieces move, decided the legend was confirmed. You have been carrying this belief for years, possibly decades, probably without ever questioning it again. And the reason I am telling you this today is not to embarrass anyone. It is because the real story of what actually happens when a worm is cut, and what a worm actually is, and what it does inside your soil every single day, is so much stranger, and so much more important, than the comfortable myth ever was. Stop. Before you reach for the spade again, or turn the soil without looking, or let your children handle earthworms the way children handle earthworms, there is something you need to understand about what you are actually holding in your hand. Because the earthworm is not the simple, passive, replaceable creature the legend implies. It is one of the most biologically complex, ecologically essential, and neurologically extraordinary animals living in your garden. And what happens when you cut it in half is, in the most precise scientific sense, a tragedy. Not a multiplication. Today we are going to follow what actually happens. To the worm. To your soil. And to the invisible system that every garden, every field, and every forest on this planet depends on. In ways that will change every time you pick up a spade from this day forward. Let's start with the legend, because it deserves to be put down clearly and finally. When an earthworm is cut in half, one half lives and one half dies. Almost without exception. The anterior half, the front section that contains the mouth, the brain, and the majority of the vital organs, has a reasonable chance of survival if the cut is made far enough from the head, if the animal is healthy, and if conditions in the soil allow the wound to seal quickly. The posterior half, the tail end, almost always dies. It may continue moving for hours after the cut, which is what convinced generations of observers that regeneration was occurring. It is not. The movement is the result of local nerve activity in a severed segment, nerves firing without coordination or intention, the mechanical residue of a nervous system that no longer has a center to report to. The tail is not recovering. It is finishing. And here is the part that stopped me the first time I read it clearly in the entomology literature: the movement of a severed worm half is not a sign of life recovering. It is the last signal of a nervous system that has just lost everything it needed to function. What looks like survival is actually the precise appearance of something ending. But the mythology of the worm does not end with the two halves. Because the earthworm's nervous system is the key to understanding everything remarkable about this animal, and it is something that almost no one who gardens has ever been told. An earthworm does not have a brain in the way you have a brain. It has a cerebral ganglion, a cluster of nerve cells near the front of its body, which coordinates behavior. But its nervous system does not stop there. Running the entire length of its body is a ventral nerve cord, a distributed neural architecture in which clusters of ganglia at regular intervals along the worm's body each process local sensory information and coordinate local movement independently. In practical terms, this means a single earthworm is capable of responding to its environment along its entire length simultaneously, without every signal passing through a central processor. Each segment of the worm's body is, in a limited but real sense, neurologically semi-autonomous. It can sense, respond, and react locally, even while the whole animal is coordinated by the front ganglion. This distributed neural architecture, a system that processes information at the point of input rather than routing everything through a center, is precisely the model that robotics engineers and artificial intelligence researchers are studying to design robots capable of moving through unpredictable terrain without centralized computation. The animal you just cut in half with your spade is the biological blueprint for a field of advanced robotics research. And the half that kept moving for 3 hours in your garden bed was demonstrating, in its death, the very principle that engineers are spending millions of dollars trying to replicate. Now let's talk about what the worm was actually doing in your soil before the spade arrived. Because this is where the story moves from biology to something that concerns every vegetable, every flower, and every tree you have ever tried to grow. An earthworm moving through soil is not simply burrowing. It is manufacturing. As it ingests soil material and passes it through its digestive tract, a process that involves a specialized muscular gizzard, a series of intestinal chambers, and a community of symbiotic microorganisms living inside it, the material that exits the worm at the other end is chemically and biologically transformed. Earthworm castings, the technical name for what the worm deposits as it moves, contain available nitrogen at concentrations 5 times higher than the surrounding soil, available phosphorus at concentrations 7 times higher, and potassium at concentrations 11 times higher. These are not improvements in the sense of adding external nutrients. They are transformations, the conversion of locked, unavailable mineral compounds into the exact ionic forms that plant roots can absorb directly. A worm does not fertilize your soil the way a bag of compost does. It processes your soil the way a refinery processes crude material, converting raw mineral mass into a precise and immediately usable form that nothing else in the garden can replicate at that scale or that speed. And the tunnel it leaves behind when it moves is not simply a hole. I remember reading the first detailed studies on earthworm tunnel architecture and understanding, for the first time, why the soil in gardens that have been heavily tilled for years consistently underperforms compared to soil that has been left largely undisturbed. An earthworm tunnel is lined with a thin layer of mucus, the same protein-rich secretion that allows the worm to move through soil with minimal friction. That mucus layer is not just a lubricant. It is a microhabitat. Research examining the microbial communities inside earthworm tunnels has found bacterial and fungal diversity in the mucus-lined walls of these tunnels that is measurably higher than in the surrounding bulk soil. The tunnel is not a passage. It is a corridor of biological activity, a channel through which water moves more efficiently, through which air reaches deeper layers, and through which the microbial networks that your plant roots communicate with are distributed through the soil profile. Every time you turn your soil with a spade, you are not aerating it. You are collapsing a system of biological infrastructure that the worms in your garden spent months building. And the worm you cut in half was, at the moment of the cut, in the middle of building one of those tunnels. So what should you do differently? The answer is practical and immediate. Stop tilling soil that does not need to be tilled. The no-dig approach to gardening, which has moved from the margins of horticultural practice to the mainstream of contemporary soil science over the past decade, is built on a single foundational observation: earthworm populations in undisturbed soil are consistently larger, more active, and more biologically productive than earthworm populations in regularly cultivated soil. When you must use a spade, move slowly and look at what you are turning. When you find a worm, move it to the side rather than cutting through it. When you finish, understand that what you have disturbed is not dirt. It is a living system of tunnels, castings, and microbial corridors that the worms in your soil built specifically to make your garden work. The earthworm has been processing soil on this planet for over 500 million years. It was here before the dinosaurs. It will almost certainly be here after us. And what it does in your garden, every night, in the dark, without any acknowledgement or assistance from you, is the foundational act of terrestrial biology. The tunnel that closed behind it. The casting it left in its path. The distributed nerve cord that felt every grain of soil along its entire length and responded with the precision of a system that took 500 million years to develop. This is what you hold in your hand when you pick up a worm. Not a simple creature. Not two creatures waiting to happen. One extraordinary animal doing work that nothing on earth can replace. Put it down gently. And the next time someone tells you that cutting a worm in half makes two, tell them what actually happens. And tell them what was lost. But there is one more thing about the earthworm that deserves its own moment, because it is the piece of this story that I find most difficult to forget once I understood it. The worm you find on the pavement after a rain, the pink, glistening, almost translucent creature lying exposed on the stone, did not come to the surface to drown or to find warmth or for any of the reasons people most commonly assume. Research studying earthworm surface migration has found that the primary trigger for emergence after rain is not flooding of burrows. Most earthworm burrows drain efficiently and do not fill with water during typical rainfall. What actually draws them to the surface is the opportunity to travel. Earthworms cannot move efficiently through dry soil. Rain-saturated ground allows them to migrate across the surface at speeds they cannot achieve underground, covering distances in a single night that would take weeks of underground movement. They are not escaping. They are traveling. Colonizing new ground. Distributing themselves across your garden in ways that underground movement cannot achieve. The worm on your pavement after the rain is not lost, not dying, not a creature to be rescued out of obligation. It is an explorer, moving with purpose across a surface that the rain has made briefly accessible, following a biological imperative that has been doing this on wet surfaces for longer than land plants have existed. Pick it up if you must, and move it to soil. But understand that it knew exactly where it was going. Have you ever watched an earthworm move through freshly turned soil, or noticed the difference between tilled and undisturbed beds in your garden? Tell me about it in the comments below. I read every single one, and the observations this community makes are some of the most careful and detailed I have ever encountered. And if you want to understand another creature that has been doing irreplaceable work in your soil, one whose biology is even stranger than the worms, the next video is already waiting for you.